thermochemistry. Did we talk about how we wanted to go from less stable molecules to more stable molecules? Are we sort of talking about now in more detail what makes for stable bonds in a molecule, what makes for less stable bonds in a molecule? So that's sort of how 6 would tie into what the current topic is. If I were to take H2 gas, a Cl gas, could I perhaps end up making 2 HCl gas molecules? And then maybe ask you what would delta H be for that reaction? Could you figure that out with the information on that board? Probably the answer is yes, even if you don't know what it is right now, right? Does anything up on that board seem to relate to what I have here? Any of those numbers relevant? Which ones?
The H2 gas conversion, yeah. And then the Cl.
To break these two apart, would I have to add 436 kilojoules per mole? And what was another one?
The Cl 243 kilojoules per mole.
To break the 2 chlorines apart would take 243 kilojoules per mole. What we're going to say is delta H equals approximately bonds broken. Wouldn't that be the sum of those 2 numbers? When I make a bond, wouldn't that be exothermic? Breaking bonds was endothermic, making bonds would be exothermic. So I'm going to say minus, in other words, that's going to make it exothermic. Minus bonds made. Do I know anything about the bonds that were made in this reaction? Don't look just a foot to the right of hydrogen flowing. Don't do that. Do I have HCl up there? To do this sort of a question, you'd have to have a table with these numbers. Do you think there's a much larger table of a whole bunch of numbers already towards the end of this chapter? And if I were to give you something like this on a test, I'd have to do something like this, a whole bunch of numbers, some of which are worthless. Right? You're not going to need the oxygen single bond strength. So there probably would be, if I gave you something like this on a test, some numbers that you don't need whatsoever, so that you'd have to pick and choose which ones you really need. But hopefully it's not too hard to pick and choose which ones you really need, right?
As long as they're labeled.
Yeah, yeah. Let's see, so HCl, 431 kilojoules per mole. And aren't I making 2 of those? I'm making 2 HCl's. So I'm going to have to double that amount when I do my calculation. So 436 kilojoules per mole plus 243 kilojoules per mole minus 2 times 431 kilojoules per mole. Negative 183. And over here I use the squiggly line equals sign. In some cases it can be an approximation. Some reactions might be liquid phase reactions. You might be doing them in water or something like that. But these measurements are all in the gas phase. The fact that they wouldn't be exactly the same in the liquid phase is partly why I'm throwing in the approximately equal sign bit. And if I talk about a carbon-carbon single bond as 347, not every single carbon single bond is exactly 347, that's just an average number. Can make a little bit of sense why it's approximately equals to. Bad news, that's the end of the chapter. Good news, that means we get to start the new chapter Thursday. Yay, new chapter!